Good morning, guys. Today we look at my 4x4 off-road skateboard. Let's take a look. All right, so this is an off-road 4x4 skateboard that I built over the last, I'd say about 7 or 8 months. And the initial idea for this came from looking out my back door, back of my house there, to this wide open park and realizing that in the wintertime it snows over in this park. And I've got a couple of electric bikes that I ride back here in the snow, and it's a lot of fun. But I was thinking, is there a way to run in the snow, almost like a snowboard, but something I could use in the summer as well? So I thought, you know what, a large skateboard would work. I've got a small electric street skateboard that I built from scratch, but I wanted something I could ride in the grass. So to that end, I built this. Now this skateboard is 6 feet long and 34 inches wide. So it may not look that big, but to give you an idea, I use this RC car pistol grip transmitter to control it. And there it is sitting on the board. So it's pretty large. And so as I mentioned, I use an RC car pistol grip transmitter, in this case Futaba digital transmitter. I like using a digital transmitter for skateboards because you can program throttle endpoint and exponential and different things in to make the board more usable in a human propulsion application. You just the steering doesn't get used. Essentially, what this board is almost like a large RC car that is big enough for a person to ride. So in the middle of the deck right here, there are 2 large lithium polymer batteries. They are 6-cell, 20,000 milliamp hour each, or 20 amp hour, and they're wired in parallel. So the pack is 24 volts, 40 amp hours. It's good for about 45 minutes of run time on a full charge. That's with me bashing pretty hard, or about an hour of just kind of playing around. Underneath this cover here is a motor controller, and underneath the other cover at the rear is another motor controller, and those are Castle Creations Mamba XL controllers. They're designed for large scale, 1/5 scale radio control cars. So they'll put out a couple hundred amps each. And so inside the boxes is also a cooling fan. So they're in a sealed box. It's gasketed all the way around to make it waterproof. But air is circulated around through the box, along the aluminum frame rail, through this other box, and through the aluminum frame rail. And that is to cool the controllers down. And this is an aluminum deck. So let me tip it sideways here. So there's the underside of the deck, or the chassis. This is where the batteries are. You can see it hangs down just a touch to make room for the batteries. So air is circulated around this deck in order to cool it. These couple holes here were going to be for charging leads. Those will be capped off. But so the deck becomes a heat exchanger to cool down the controllers. So the deck has all been TIG welded together. It's 6061 aluminum that I TIG together myself in my shop. And there is a small amount of concave to the deck. So if you look, you can see that it sweeps up at the sides like a standard skateboard deck would do. This connector here is for to power it up and also to charge it. It connects the batteries to the controllers at both ends of the deck. So the drive system at both ends is identical. And the board is pretty much symmetrical front to rear, although there are some specific differences that I'll get into shortly here. The motor is an Astroflight Industrial Series motor. In this instance, it's a 3210 motor that is 3 turns. So this motor will run a little over 10,000 RPM at full throttle. Admittedly, I have the throttle endpoint at the transmitter set for 60% maximum. That way the board, being geared for 24 miles an hour, really only goes about 13 or 14, 15, something like that miles an hour in its current guise. Any faster gets a little bit scary for me. I'm not quite used to it yet, so I can always turn the speed and power up if I need it. Again, same motor front and rear, and each motor is capable of putting out somewhere in the range of about, I'd say 7 horsepower, somewhere around there at peak. They in this application, I don't think they're seeing more than about 4 horsepower each under peak acceleration, so that's 8 horsepower. So again, the board has probably more like 14 horsepower total. And I'll ride it, and I'll also, I'll run it without me on it, so you can get an idea of the acceleration power that the drive system has. So this is similar drive system to my bicycle drive systems, in that you have the motor to a toothed belt. This is a 5mm pitch HTD profile toothed belt to a pulley, and in the center of the pulley is a torque limiter. What that does is it allows the pulley to spin independently of the shaft if you overload the system, and that torque limiting feature is adjustable by tightening or loosening this large spanner nut. So the tighter it is, the more pressure on this Belleville spring, and the stronger the clutch is before it slips. And I found that these torque limiters are helpful to minimize driveline load because of how much torque the motors have. Electric vehicles have crazy torque at low RPM, so a torque limiter is pretty important. Now, the secondary second stage, I should say, you've got the belt drive to a jack shaft, and the second stage is a chain from the jack shaft to the axle. Now, the reason that there's a chain, in this case it's a number 35 pitch, which is a common go-kart chain, number 35 pitch chain. The reason there's a belt on the primary stage and a chain on the second stage is because toothed belts run best at high RPM and low torque loading, whereas chains work better at low RPM and high torque loading. So from a gearing standpoint, the primary reduction from motor to pulley is running at high speed and relatively low torque. That torque is multiplied while the speed is slowed down to the second stage. So the first stage runs high RPM without much loading. The second stage is much lower RPM with higher torque loading. So it's proper application of technology in that you've got belt on the primary stage, chain on the secondary. I do that on all of my bicycles. It works better. Now, tucked down inside here is a garden tractor differential. Let's see if I can get an underside view. So a garden tractor differential, and that differential has been modified in a number of ways to work in this application. It is just a standard differential that I got on eBay. I ordered 2. For a vehicle like this, you can't have a solid axle because it just won't steer. A lean steer vehicle, you need to have independent or differential rotation of inside and outside wheels for steering, and that requires either a separate drive unit for each wheel to spin independently, which gets expensive and very complicated, or a differential between each to divide the load between each axle. So I went with differentials. Now, normally this differential is designed to be mounted mid-axle with the shaft running at each side in the garden tractor application. In this application, I've got the steering kingpin here, so I couldn't put the differential in the middle. I needed to offset it. Now, that required a couple of things. First off, the long axle was too short, so I had to cut that axle, extend it, and sleeve the axle inside this housing. This aluminum housing just houses the rotating axle inside. So it's a 1-inch axle that I had to cut, extend, and then weld a sleeve to extend it for both the front and rear axles. This axle coming out the side, I had to shorten, and then I also had to machine a keyway. You can see the key slot there. Machine a keyway into that axle. On top of that, the differential the differential housing itself was too wide, and it wouldn't fit between the wheel and the chassis. So I had to cut and narrow the housing, modify it. It's been internally modified, externally modified. The shafts have been modified. Just a lot of work involved. The The axle tube here is just straight. In this instance, I had to TIG weld a box to go around the differential. The chain tension is adjusted via moving the drive unit fore and aft, and it applies more or less tension to the chain. So let's see, it's got double wishbone suspension, and we'll show you that here. See if I can hold the camera properly. So there's the suspension and how well it functions. You can see it's a double wishbone, lower arm and upper control arm, and the upper control arm is mounted on turnbuckles that are threaded in opposing directions on both sides. So I can loosen up the lock nuts and rotate this without disconnecting either end. Just loosen each lock nut, rotate the center link, and that changes, it extends or contracts. What that does is it adjusts the kingpin angle here. If I lengthen this upper control arm, it shallows the kingpin angle for the steering, shallows it. If I shorten this link, it steepens the kingpin angle. Now that brings up an interesting point. The front kingpin angle is at a far steeper level than the rear kingpin angle. On the front, the kingpin angle is steep, and on the rear axle, it's shallower. That allows for about twice as much front steering as rear. This is a skateboard in every respect, and it lean steers. And lean steering allows both the front and rear wheels to steer at the same time. Now that front and rear steering means that it will turn sharper and tighter, but if you have the rear and steer at the same ratio as the front, then it ends up squirrely. While you're riding, it wants to weave back and forth. So I've shallowed the rear steering kingpin angle and steepened the front steering kingpin angle. That gives me about twice as much steering at the front as the rear, makes it much more stable. This is a steering dampener. It's designed for a motorcycle, and what it does is it helps dampen some of the tendency to weave. As I mentioned, the steering kingpin angle affects the weave, but also a lack of dampening does. This vehicle weighs, I haven't weighed it, but I'm guessing maybe around 80 pounds. The axles are pretty heavy, and they have a large moment of inertia as they turn, and that also contributes to a weave. So I added steering dampeners front and rear. They're like a shock absorber, so as the chassis leans and as it steers, the dampener resists that, and in the same way any fluid dampener does. You can adjust the stiffness here. That's softer, that's stiffer, and both front and rear are adjustable. So these are steering centering springs, and I've got the springs mounted front and rear. The rear springs are slightly thicker than the front. You can see the fronts are relatively narrow, and the rears are a little bit heavier. There's narrow springs inside, encased with wider springs on the outside. There's about 50% heavier centering spring rate on the rear than the front, and I've been experimenting with handling qualities of each setup. So I'll show you here. I'll lean it. So standing on the board, leaning it left and right, you can see the way everything functions. The centering springs, the steering dampener, and so that's the way the system functions. And again, it is a skateboard, so as you lean, it steers. And so the suspension is wonderful for running over some very hard, very large bumps that we've got in the area. I've never seen a skateboard with suspension, so I wanted to give that a try. So we'll go ahead and ride it around a little bit here. the controllers make an initializing beep as they would with a normal RC car. So that stutter is just the motor starting up. That's a pretty common thing on a sensorless motor setup. So you can see the left-right steering. So we'll go ahead and run it a little bit here. Watch, I'll go ahead and give it a little bit by itself so you can see the power it's got. Pretty powerful. So I'll go ahead and set the camera up and get some footage of running it around. So that's it. Just figured you guys would get a kick out of seeing it. So much that I could say on this thing. It's just, it has encompassed a lot of my time, and it's all of my own design. I've never seen a 4x4 off-road skateboard with suspension, and again, it was primarily designed for the snow, but to be able to run it in the summertime as well. So anyway, I'll update you guys as I have more information on it, as I don't know, debug things here and there, but for the most part, it's pretty well just running fine. So anyway, thanks a lot, guys. I appreciate you watching the channel, and I've got more projects like this that I'm going to be giving walkarounds of and technical descriptions. I'll probably start a build blog of a couple of projects I have coming up so you guys can see what goes into a project of this magnitude. I've got probably 250 hours of time invested in the design and build of this board, and it's a lot of fun to ride.